All right, let's take a look at the quiz that I just passed back to you. I don't think I need to go over every problem of this, do I? All right, because I think a lot of you guys did pretty well on most of this. Let me get the quiz out. Where did I put it? There it is. All right. I put the answers, didn't I, for everybody? If you got it wrong, did I put the answer? Okay. All right, so I don't have to go over all the answers, but let's hit a couple. I think 4, 5, and 6. That might be a good starting point, do you think? Yeah. So let's do those.
6 was the hardest.
Yeah, I agree. Yeah, 4 is really straightforward. 5 was a little bit tougher. 6 was the toughest, I would say. So do you remember the formula? You got to know the formula. Everybody's paying attention now, right? You got to know the formula. What is the formula to find the length of the arc of a circle? Apothum?
Bro, that's like the least thing you can be worried about when you're trying to tell me what to do.
No, it's definitely something to worry about. Because if you say apothum, that's different than theta, all right? It's a completely... Yeah, but, well, you got to say what you mean, all right? So it's theta over 360, then what? We're finding the length. It's 2 pi r, okay? Do not put pi r squared. I don't know if anybody did. I don't think so. I didn't really check to see if anybody did. But what is pi r squared? It's the what? It's the area, okay? This time, Tim, if you can't calm down, you can go sit in the office the rest of the period. It's going to be on YouTube, so you won't miss anything. So if I have to keep talking to you, you will be in the office. You understand? Not because I want to get you in trouble, just because I want to be able to teach. All right? I want people to be able to listen and pay attention. You're all geared up. I can tell. All right? It's the last week. I get it. It's right after lunch. I get it. But you got to have self-control. All right? Have some self-control. All right. Here we go. So it's there we go. It's all there for you. There's really nothing to work out. There's no algebra to do. It's just plug and chug. And just using your calculator. You just got to know how to use your calculator. I don't know. Did anybody, I didn't really check, but did anybody get the problem wrong because they just put in their calculator wrong or anything like that? Anybody know? All right. Well, we'll see. So let's put it in here. We know the theta. What's the theta? It's the central angle, right, which is 75 degrees. So, I don't know. Let's just do it down here. All right. So it's 75 over 360. And then it's 2. And then it's pi, and then it's r. And they tell you the r. What is it? It's 8. So basically, you just have to put that into your calculator, okay? And you got to know how to do it. Make sure you do it. Just because it used to be back in the day, if they said, oh, here, use a calculator. Oh, I can get all the problems right. Because all it was just addition, subtraction, right? Multiplication, division, right? Way back. But now, it's a little more complicated in your calculator. So you need to know how to do it. So, just stick that all in there, and you should get, actually I'll put a little squiggle here, 10.5. This is in inches, so your units are in inches. Make sure you know how to put that in your calculator. Yes, sir. Well, you might. What did you use for pi? Well, let's see. If you use 3.14 and you put this into your calculator, you should get 10.5. Or round it. It doesn't say what to round it to. I don't know if on the test I say to round it to a certain decimal place, but if I don't, listen, everybody hear me? If I don't say to round it to a certain decimal place, round it to the nearest tenth. Everybody got it? 1 decimal place. All right. If it doesn't say, don't just round it to the nearest whole number. Definitely don't do that. Okay. But round it to 1 decimal place if it doesn't come out even, right? If you get a decimal answer. So, if anybody's watching this on YouTube, you will not be able to see the calculator. Sorry about that. There's something I got to change on the OBS program that I used to record this. And I don't know, it didn't work last time. I don't know why. So I just have not taken the time to try to figure it out. But I got a calculator up. And I'm just going to plug this stuff in. So here we go. Let's see how it works. So 75 divided by 360. Actually, let's do it like this. Yeah, you could keep going like this, I guess. We're not going to hit times, though. You know what I should put? I could do this. I could put that in parentheses. Oops. Oh, I thought it would just put a parentheses there. Now I got to type everything else in. Oh, goodness. Let's just clear that. Let's start again. All right. What I would do to make it easier on the calculator work, I would go 75 times 2 pi times 8 and put that whole thing over 360. I think that'll streamline a little bit, make it a little bit easier for you. Does that make sense? All right, so I'm going to go, and I don't know if I need parentheses or not. I'm going to put them in there anyway. So I'm going to go what? 75 times 2 times, I'm not going to use the pi button, I'm going to use 3.14, just so that we stay consistent, and then times 8. All right, and then I'm going to close the parentheses, then I'm going to put divide, thank you, then I'm going to put divide, and by what? 360, right? 360. And let's hopefully, 10.46. What is that? 6 round the 4 up to? A 5. So if you put it in a calculator, you should get 10.5 if you use 3.14, right? Maybe you put that in and then you simplified that, or I don't know, first, and then you put the other stuff in. Well, don't do that. Put in everything all at once. And if you see a pi, put in 3.114 or 3.14, and then you should get 10.5 when you round it to one decimal place. Everybody should, no matter what calculator you use. Everybody good with that? All right, so make sure that you do that correctly. All right. Just got to clear that. Just move that calculator out of the way for a minute. All right, let's do the next one. So it's the same formula, isn't it? It's this formula right there. But they give you different stuff, and they ask you for something different. So they actually tell you the length. Now, they tell it to you kind of weird, don't they? 3 pi over 2. But that actually makes this kind of easy, because what happens to the pi's? When you did the problem, they cancel out, right? All right, so don't worry about this being a 3 pi over 2. It really does not make it any harder. It actually makes it a little easier for you to do the algebra. I really think it does, okay? So let's do that down here. So the length, right? I'm not going to rewrite that every single time. It's already there. So what is the length of the arc? 3 pi over 2. It's not 3 over 2. It's 3 pi over 2. It's 3 times 3.14 divided by 2. That's what that length is right there, okay? Again, it's a weird number, but that's how they write it. And you're going to find out later on in your math career that we're going to be doing things with, I don't even want to get into it right now. So let's just keep going. So that's the length equals what? Theta over 360. Well, do I know the theta this time? Yeah, I know the theta. Well, I knew it this time too. But it's 45 over what? 360. And then what? Times 2. And I'll tell you what, if you want, let's just put everything on the top. Times 2 times pi, right? I'm just going to put pi. I'm not going to put 3.14. I'll show you why. Times r. Thing is, we don't know the r, do we? So really, it's just all that over 360. If I wanted to simplify, I could. I'm going to show you how to do it all in one shot in your calculator, okay? So first of all, what am I going to do first? I want to get r by itself. So I want to get rid of all this stuff. I want to get rid of 45, 360, the 2, and the pi. What's the first thing I can get rid of super easy? The pi. So if you divide both sides by pi, right, they both cancel out. Everybody with me? Divide this by pi, the pi's cancel. Divide this by pi, the pi's cancel. So that was kind of nice. So I don't even have to worry about that being a 3 pi over 2 anymore. Yes? Okay. All right. Now, we could do this a couple different ways. You could go 45 times 2 is what? 90. And then 90 goes into 360 4 times, doesn't it? So you could do it that way. It's perfectly fine. All right. But if you don't like that, watch what you could do. You don't want the 360. It's on the bottom. So where do we put it? If I want to get rid of the 360, how do I get rid of something that's being divided? I multiply, which does what? Puts it on. Okay, yep. If I put it up here, multiply it, that'll cancel out. But then where do I put it over here? On the top. Okay, so the 360 goes. Everybody got that? You know 45 times 2 is what? 90. So let's just think of it as a 90. So how do I get rid of a 90 if it's being multiplied? I divide it. Or if it's on top on this side, where's it going to be on this side? On the bottom. So let's just put a 90 right there. Everybody see that? All right, so that would cancel out. So there, you got r by itself. So r equals all this mess right there. So what do you do with all that mess? Put it where? Into a calculator. That's right. All right. Now you could simplify some of this right off the bat. Again, the zeros cancel out, don't they? I was going to do it all in the calculator, but it actually works out real nice and easy. Okay, so let's just do it without the calculator. You okay with that? So watch. Then the 9 goes into 36 how many times? 4, okay? And then I got a 4 on top and a 2 on the bottom, so the 2 cancels out with the 4 how many times? Twice. Now what am I left with? 2 times 3, which is 6. So what's r? It's just 6, all right? And it comes out perfectly to 6. It's not an approximation. It's exactly 6. So you could put 6.0 because, but if it comes out perfect and it doesn't come out to a decimal, I would just keep it r equals 6. If you wanted to and you wanted to do all that in your calculator, you could have done it. Let's just do it for fun. So what do we have? I got all that stuff crossed out, but we can kind of remember it, can't we? So what is it? 3, oops, I got to turn this on. There we go. So I've got what? 360? What else is on top? Times what? Times 3, right? I don't have to do the pi because I know I canceled out the pi already, so don't have to worry about that. All right, and then take that whole thing. Let's do this. On this calculator, what should I do? Let's do this. Let's clear it and do it again. So if I got more than one thing on top, what did I do the last time? I put it in what? Parentheses. So let's do that. 360 times 3 times 3. And then there's nothing else on top, so I close the parentheses, and then I take that whole thing and I divide it by, and then put that in parentheses. What do I have on the bottom? 90, right? 90 times 2. And that's all on the bottom, right? Is that everything? Now, if I hit enter, boom, look at that. Exactly 6. No approximation. It's exactly 6. So if you like the calculator, you want to use it, perfectly fine. I got no problem with that. If you would rather just start canceling a bunch of stuff out, and then if it comes out perfect, great. If it doesn't come out perfect, like right here, I could have canceled a few things out here, right? 5 goes into 75 and 5 goes into 360. You might be able to take the 2 into it, the 8 into it. You could do all that if you wanted to. All right, but if you don't like doing that stuff, you just want to chuck that into a calculator, feel free. It's perfectly fine. Okay, same thing with this. Does that make sense? All right, let's do this one. Now this one was the one that was a little bit tougher. Oops. It doesn't, there it goes. Okay. All right, so it's the same formula as that length equals thing. So what is the length of this one? The L. Yeah, 35 pi over what? Over 4. That's the length, okay? From here to here. That's the L. Everybody got that? Yeah. Equals theta over 360. Well, we knew what the angle was, the central angle was for the first two, but we don't know what it is here. So what are we going to call it? Call it theta. That's the name of it, right? Theta over what? 360. Okay? What else? 2, right? So let's put this all on top now. Times 2 times pi times r. This time I do know the r. Didn't know it on the second one, but I know it on the third one. What is it? Times 15. Put a little dot there for times and 15. The math is really the same. Remember I said I thought this was a little harder? It's really not. It's about the same problem, isn't it? Right? The same level of math, the same level of algebra, because instead of having the r by itself, we just have the theta by itself, and we're getting rid of the stuff just like we did on here. So it's really no different, 5 and 6. As far as the level of difficulty, it's no different, okay? It's obviously different because we're solving for something different, but so here we go. Let's go through it again. I want to get that by itself. I want to keep that there. I want to get rid of everything else. So what am I? Well, first of all, what can happen? Yeah, cross out the pi's. They both cancel each other out. Then I don't have to deal with the pi. That's nice. Let's move the 360. So if it's on the bottom, where do I put it over here? Put it on the top. Okay? Over. Now, look at this stuff on the top. So we got rid of the 360. Now I got a 2 and 15. Can you just do that in your head? What's 2 times 15? 30. So where do I put the 30 over here? On the bottom, because it was on top here. We put it on the bottom over here, and so you get a 30. All right, everybody good? And then that is what we're putting into the calculator. If you wanted to start canceling stuff out and all that kind of stuff, you absolutely could. It does come out. This one does come out to a nice whole number, but you don't know that to begin with, do you? So I would just go ahead and put it in the calculator. So let's do that. So here's the calculator. What am I going to do first? 360 times 35. Since there's two things, I'm going to put it where? Go ahead. I'm going to put it in parentheses. So I go 360 times 35. I'm going to close the parentheses. Then I'm going to hit divide. Then I'm going to hit, and we know what that is. What's 30 times 4? It's 120. So you should figure that out. 120. And then look at that. Comes out to a nice number. Okay, so that's cool. So it's 105. 105 what? What are we finding here? We're finding theta, which is it's an angle, it's in degrees, right? So theta is 105 degrees. That's all there is to it. Did that make any sense? Yeah. The algebra wasn't that hard, was it? You got rid of something on the bottom, stick it on the top. You get rid of something that's on the top, you stick it on the bottom to the other side. Right? Yep, see you guys. Good luck. And then you just throw it into your calculator and you're good to go. So make sure you know how to use your calculator. Logan, go. Go. All right. So make sure you know how to use your particular calculator. All right. I have like 2 calculators up here. But if you're not used to using this particular calculator, it may do things a little bit differently. Probably not that much different. Okay, but make sure that you've practiced this on a calculator so you know how to get the question right on the test. Okay? All right, I think that's all the calculator work we're going to do, so I'm going to get rid of the calculator. And let's take a look at this one right here. So it seemed like to me 9 and 10 were a problem. Yes? For some of you, you got it, but some did not. But we'll do all 4 of those. So I kind of got you started on this the day before we took the quiz, didn't I? I think I drew the picture. I didn't put any actual numbers in here, but I said, okay, you're going to need to know that this angle is the inscribed angle, and it's half of the arc, and blah, blah, blah. So I gave you the picture. Did anybody actually go and look in the book for that example? Wasn't this either on a homework problem or an example? Nobody did it? Well, you should have, all right? I showed you the picture. If you were going to study for this quiz, you should have looked in the book, right? Found the problem, and then gave it a shot. I don't know 100%, but I'm pretty sure they might be the same exact numbers, all right? I don't know. Anybody got their book open? Can look real quick? Not that it matters. It doesn't matter. But anyway, I'm just saying that all to say that we've seen this kind of problem before. All right, so where do we start? Well, I'm just going to start. I'm not even going to look to see what we're trying to solve for right now. I just want to look at the numbers and let's find the easiest things that we can find so far. Let's start with this 49. Okay, what does that 49 tell us? It's an inscribed angle, isn't it? Okay, so what did we learn about inscribed angles? It's half the arc that it cuts off. Where does it cut off? From D to H. So if this is half of this arc, what's the arc then? It's double this angle. Would you agree? So yeah, so that's 98 degrees. I don't even know if they ask you to solve for that, do they? DH? No, they don't. But we are going to use it. All right, so I'm just going to go through here and just find stuff that I know. Let's do another inscribed angle. That would be this 31 right here. So it goes to E and it goes to F. So what's this arc right here then? 62, right, because that's double this angle right here. Everybody with me on that? Are there any other inscribed angles? No.
Use the 62 right now.
Use the 62?
We're not doing number 7.
Well, let's just find out other stuff. Let's see if we can find all the arcs. Trying to see what we're going to do next. Where did I go from here? That's 62. What did I do here? How did I get that? Yeah, add up all the arcs. Okay, so look, yeah, from there we go. Yeah, why didn't I see that? I don't know why. But watch, from here, let's start at H. Everybody see that? We're going to start at H. Let's go to this. So that's what, 98, right? And then we went to here, that's what, 94. And then we go to here, which is what, 62. And then we go, that's to here. And then we go to there is what? 48, correct? So the only thing we're missing is what? What arc are we missing? HG. All right, so how do we find HG or GH? Well, we got all the arcs except for that one. So what is it all the way around the whole circle? It's 360. And then what do? It's 360 what? Minus whatever that is. Oops, it's a 363. Forgot some stuff. 360, that's a little messy, but that's okay. 360 minus whatever that is. And that eventually comes out to 58 degrees. So that's this angle, or this arc right there, 58 degrees. All right? So that's 50, oops, why am I not writing the numbers? There we go, 58 degrees. After that, everything else should kind of fall into place a little bit. All right, well, at least the arcs, this EG. Let's find EG. That's from here to here. Oh, that's easy. Look, from here to here is 62. From here to here is 48. So what's the whole thing from E all the way to G? Just add them up. That's right. 62 plus 48. And that's 110. So that would be 110. Like I said, most people got those two right. If I remember right, that just seems to me like a lot of people got the first two. Okay, it was the next little part that caused a little bit of a problem. Let me get rid of this mess right here. There we go. Just cleans it up a little bit. All right, what are we trying to find now? DJE. Where is DJE? Let's do this in a different color. Let's do this green. DJE. Where's that? DJE. It's this one right here. All right. Where are we going to go from there? Say that again. EDJ. EDJ. Yeah. And can we find that? Yeah, there's another. Yeah, why didn't I even, because when we were looking at all the inscribed angles, yeah, this is also an inscribed angle. They just don't tell us what it is, right? Maybe that's why I forgot about it. Okay, so you got an inscribed angle here. You got one here. You got one here as well, okay? And now we should be able to figure out what that angle is. Where does it cut off? It cuts off from E all the way to G, which is how many? 110. So what's the angle then? It's half of 110. Correct? Which is 55. So that is 55. Now we're rolling. So now I can find this angle right here. Why? Because I got a triangle. What do the angles of the triangle add up to be? 180. So I add up 55 and 49, whatever that is. What is that? 90, 104, is that right? 104. So I go 180 minus 104, which is 76. So this angle right here is 76 degrees. And that's what I want to find, isn't it? DJE. So that's 76 degrees. Everybody see that? So you had to look at that inscribed angle and you say, well, it cuts off from here to here. Well, I figured what that was, right? That's 62. That's 48. Take half of it, it's 55. Take those away from 180, you got 76. Well, this is also going to be 76 degrees, isn't it? What's the name for those two angles? They're vertical angles, okay? Let's go HKJ. Let's go different color again. Let's go as blue. All right, HKJ. Where's H? Right there. There's K and J. Oh, this angle right here. That's what they want you to find. Oh, that's kind of easy. We've already done this once before, right? To find the 76. So how do you find that blue one right there? Is it half? No, this is not an inscribed angle. It's not half a 98. Okay, it almost looks like it is, but it's only half a 98 if that point was on the circle itself. It's not. But it is part of this little triangle, though. All right, that's what you want to see. Yeah. So 180 minus 76 minus 31, or what does that be? That'd be like 107? Is that right? 107, so 180 minus 107, and what's that? 73. All right, and that's this angle right there. That would be 73 degrees. And that's the one that they want you to find, 73 degrees. We good? All right. So that's pretty much that quiz. Now, you may not have this quiz out, but let's go through some of these. This is 8.1 and 8.2. Let me get that one out so I can see it. There it is. Let's see. We don't have enough time to hit them all. We only got like 6 or 7 minutes. So, what's some good ones in there to do? 7? Okay. Let's do 7. All right, what do we know? What do we know about this? This radius and this tangent. How do they hit each other? At a 90-degree angle, at a right angle, okay? And right here as well. That's a radius. That's a tangent. So I've got a triangle, don't I? See the dotted lines? Consider that as part of your triangle. From here to here, here, here. 4 sides. So how much does the 90 and 90 add up to be? 180, all right? So what must these add up to be? 180, right? Yes, because all 4 of them will be 360, right? These are already 90 and 90, so you take away the 180. So these two have to add up to 180. So 3x plus x is 4x, all right? And what's 4x equal to? 180 degrees. And divide both sides by 4. Can you do that in your head? Watch. What's 180 divided by 2? 90. And then divided by 2 again, because it's a 4, 45, right? You could use a calculator, it's fine. You don't have to do it in your head, all right? Everybody see that? All right, so x is 45, and that's what angle A is anyway, isn't it? That's 45 degrees. What's angle C? Angle C is this one right here. So x is 45, so it's 3 times 45. Well, what's 2 times 45? 90, plus another 45 is 135, okay? So this angle is 135. All right, so that's 7 and 8 right there. All right, yes, ma'am. 3. All right. All right, let's do 3. That's a good one to do. It says find FI. Where's FI? This one right here. So from here to here. That's what we want to find. And they tell you some stuff. They tell you that AI, but they don't give you AI, do they? So what are you going to do? Draw it. That's right. Okay, so AI is 8. And AG is 6, this little bit right there. Oops, why did I put 8? 6. And what are we trying to find? We are trying to find from here all the way to there. But I'm not going to find all the way to there directly. Where am I going to go? I'm going to go to G, right, from I to G or G to I, all right? So how do we do that? Some of you guys thought this was a 3, 4, 5 triangle. Is it? It's not. Okay, if the 8 was here, then you could go 6, 8, 10. But it's not here, is it? So you have to do Pythagorean theorem. So let's do it really quick. So I don't know what this is. Let's just call it little b. Is that all right? So where do we start? Yeah. Well, let's do the b. Let's do the b first. I think it's a little easier to put the variable first. So b squared plus 6 squared equals what? 8 squared. So b squared, this is 36, this is 64. So this is just going to be what? 64, no, divided by minus 36. Is that correct? Yep, and that's what? 28? All right, take the square root of both sides. So b is equal to the square root of 28. And, but that's not your answer. Some people put that as your answer, okay, but it's wrong. So what do you need to do? Because we want to find IF. I don't want to find just IG. What is IF? It's double it. That's right. It's double this one right here, right? Because we have a thing. You can look it up. Radius, and if it's perpendicular to a chord, then it bisects the chord. You can look that up to where we talked about that. So what is IF then? Or FI? It's 2 square root of 28. Yeah, you can just write it like that. Now this actually does simplify, but I'm fine with this. All right, if you keep it 2 times the square root of 28, I'm fine. You could also put it into a calculator. I actually did not put it into a calculator. And I'm fine if you leave your answer like that. But it can't be just the square root of 28. I know I saw that a few times. Does that make sense? Yeah. Not that hard, right? If you label this stuff, right? Sometimes that AI, that line wasn't drawn, and some people freak out because they don't see the line. We'll draw the line, right, from A to I, because they tell you what the length is. Anything else? Let's just go through some of these right here. Now again, look, this radius is perpendicular to this chord, so what must be true about BC and CE? They must be what? Equal to each other. Same thing here, right? So this chord and this chord are equal to each other. All right? It says they're congruent circles, so what's true about BC, CE, IG, and GF? All 4 of those are equal to each other. That's right. Okay? So that should be kind of helpful. All right, then down here, what do we know about this? When you have a point outside here and it's perpendicular, we've already discussed this a little bit on this one. What kind of an angle do we have? We have a right angle. Why is it a right angle? Because when you have a tangent and a radius hitting at the point of tangency right here, that means that this is a right angle. Same thing with this, right? And then they give you some stuff, like number 10. GH is 25, so that's 25. EG, which is this middle one, is 65. And you just do Pythagorean theorem to find EF, this one right here. Now, if that's 25, that's a radius. What's FG going to be? It's also going to be 25. So you could have found that tangent and then said, oh, this tangent is going to be the same thing. Or you could just take this radius and say this radius is going to be the same thing. Either way, you do it. So again, we'll call this B. How would we set it up? I'd go B squared plus what? 25 squared equals 65 squared. So you would go 65 squared minus 25 squared, take the square root, and bang, that's your answer. Everybody good? That's pretty much what's going to be on the test. So you've got an extra day because you got that field trip. So make sure you study it. Go back and watch the lessons from chapter 8. Remember, 8.5, we did not review 8.5, okay? But yeah, anything on chapter 8, 8.1 to 8.5. Everybody got that? From 8.1 to 8.5. I think there's an extra lesson in there that we didn't cover. 8.5 is the last lesson that we covered, okay?